Hi guys, and welcome to Radioactivity Lesson 5. Right, first of all, let's look at our answers from last lesson. Slide. Second slide. Third slide. And our final slide. Okay, hopefully wasn't too tricky, and by the end you're getting quite fluid with being able to answer these kind of questions. Okay, moving on to today's lesson. First of all, as always, we're going to start with a bit of retrieval practice. Okay, first slide. Remember to pause, write down your answers, and when I show you the answer slide, make sure we're copying down the correct answers or making any corrections. Here's the answers. Second slide. Here are the answers. And final slide. And here are the answers. Okay, on to today's lesson. Today we're going to be looking at something called half-life. Sounds really complicated, but once you get an idea of what half-life means and how we work it out, and we do some examples together, it's quite straightforward. Okay, so first of all, what is the definition of half-life? We're talking about radioactivity. What is half-life? Okay, that is the time taken for the number of nuclei of the isotope. Remember, isotopes are radioactive elements in example to halve. Okay, it also can mean, and this is some knowledge we need from a previous lesson, it can also mean that the count rate has dropped by half its original level. Okay. Now what that means is the question may give you amount of time that it takes for the amount of nuclei in an isotope to half, or it may give you the count rate and then a time in which it took that count rate to half. And that time can be anything from a day to 10 years to 20 years. Okay, it can vary in the question, and we'll have a look at some questions moving on. Okay, now guys, as always, time to embed this information. Mini whiteboards, pen and paper, get someone to test you, or both, if possible. Okay, so pause the video and have a go at embedding these two new definitions. Okay, moving on then. Let's have a go at some examples of questions like this together. So this example says Mendelevium-257 has a half-life of 5.5 hours. If a source contains 36,000 Mendelevium-257 nuclei, how many will remain after 5.5 hours? So let's pick out a key information. So the half-life, how long it takes it to halve, is 5.5 hours. It contains at the start 36,000 Mendelevium nuclei in the radioactive source. And then it's telling me how many would remain after 5.5 hours. Okay, so what we're going to do is we're going to start off by drawing how many it starts with. So 36,000 nuclei to start off with. And then every 5.5 hours it halves. So I'm going to draw with an arrow, and it halves, which is dividing it by 2 every 5.5 hours. So 36,000 divided by 2 is 18,000. Now, that's every 5.5 hours. And how long is the question asking me to work it out for? It says how many remain after 5.5 hours. That's all I have to do for this question. So the answer is 18,000. All I'm doing is halving the number we started with. That's all I'm doing, halving the number we started with. So make sure you've got that down as an example. Then moving on, another example below. Fermium-253 has a half-life of 3 days. If a source contains 56,742 fermium nuclei, how many remain after 6 days? So first of all, let's circle the key information. Has a half-life of 3 days. Every 3 days it halves. It starts off with 56,742 nuclei. How many remain after? And this time it says 6 days. Okay, so let's start off again just as we did before. So first of all, we've got 56,742. You may need a calculator for this one. And every 3 days it halves. So draw a line, arrow, divide it by 2. And this is every 3 days. That's its half-life. So after 3 days, it's going to be 28,371. And that's all I had to do on the last question, but this time it's saying 6 days. So if its half-life is 3 days, that's 2 half-lives. So what am I going to have to do? Well, I'm going to have to half it again. Okay, so I'm going to have to draw another arrow, divide by 2, another 3 days. So I've got my 6 days there. And what's that going to be? That's going to be 14,186. So that is my answer. That is how many will remain after 6 days. So because the half-life is 3 days, I had to half it. And then because it's saying how many will remain after 6 days, I'm going to have to then half it again. Okay. Now moving on, our final example we're going to do together. Hydrogen-3 has a half-life of 4 years. So this time we'll circle it as we go through it. If the source has an activity of 364 becquerel, what will it be after 12 hours? What do we think? Okay, and I think what the question should be saying, so we'll make a correction here, is 12 years. Okay, so apologies for the mistake there. 12 years. What will the half-life be after 12 years? So first of all, what does it start off with? It's 364 is that starts off with. Then we're going to, again, every 4 years it halves. So I'm going to divide it by 2, 4 years. If I divide it by 2, it's going to be 182. Now I've only got 4 years here, it says 12 years. So I'm going to have to half it again. Divide by 2, 4 years. Still, I'm only up to 8 years. What's that going to be? It's going to be 141. And then I'm going to have to halve it again. So another 4 years goes by, divide it by 2, half 141, which is going to be 70.5. And there we go. That would be the amount left after 12 years, because the half-life is 4 years, so I'm going to have to half it 3 times. Okay, now when we go on to our independent practice after you've got this all down, what I'd like you to do is make sure you set out every question like I have. Make sure you're following the same process. Okay, moving on to our independent questions then. Of independent practice. Make sure you're spending time writing the answers out for this. Don't rush through it. It's really important that we embed this information through doing lots of examples. So, slide 1. Slide 2. Okay, that's it for today, guys. As always, we'll go for the answers to these questions at the start of the next lesson. Thank you very much for listening. We're looking a little bit nicer today. I hope everyone's well. I look forward to seeing you soon. Bye.